Venus, the second planet from the Sun, is unique in many ways, but one of its most intriguing features is its retrograde rotation. This means that Venus rotates in the opposite direction to most of the planets in the solar system, including Earth. Here's a detailed explanation of Venus and its backward rotation. Protoplanetary disk. In the early solar system, particles of dust and gas coalesced under gravity, forming planetesimals, which eventually merged to form protoplanets. Venus likely formed from the same protoplanetary disk of gas and dust that gave rise to the other terrestrial planets, Mercury, Earth, and Mars. Size and structure. Venus is similar in size and structure to Earth, which is why it is often referred to as Earth's sister planet. It has a thick atmosphere composed mainly of carbon dioxide, with clouds of sulfuric acid, making it inhospitable to life, and the surface temperature of Venus is extremely high, averaging around 467 degrees Celsius (872 degrees Fahrenheit). Unlike most planets that rotate counterclockwise, when viewed from above their north poles, Venus rotates clockwise. This is known as retrograde rotation. Venus has an exceptionally slow rotation period, taking about 243 Earth days to complete one full rotation on its axis. A day on Venus, one complete rotation on its axis, is longer than a year on Venus, one complete orbit around the Sun. A Venusian day lasts about 117 Earth days. Understanding why Venus rotates backward involves considering various theories, each with its own set of implications. A giant impact hypothesis. A theory overview. One of the most widely accepted theories suggests that Venus may have experienced a colossal impact with another large celestial body, possibly a protoplanet or a large asteroid. This collision could have been powerful enough to alter its rotation direction. Impact evidence. Such impacts are not unheard of in the early solar system. Earth's moon is believed to have formed from a massive impact with a Mars-sized body. The same kind of event could have drastically changed Venus's rotational dynamics. Implications. If this theory is correct, it would mean that Venus's current state is a direct consequence of a violent event in its past, contributing to its extreme environment and unique rotation. Another hypothesis involves the tidal forces exerted by the Sun on Venus. Tidal interactions, particularly with a close and massive body like the Sun, could exert significant torque on a planet over billions of years. A despinning and reversal. Tidal forces may have slowed down Venus's rotation until it stopped and then reversed. This process would be exceedingly slow, occurring over hundreds of millions or even billions of years. Resonance effects. Some scientists suggest that Venus's rotation might be in a state of tidal resonance, where its rotation period and orbital period are linked in a complex gravitational relationship with the Sun. Venus has an extraordinarily thick atmosphere, and some scientists propose that interactions between the atmosphere and the planet's surface might influence its rotational speed and direction. Atmospheric drag. The thick atmosphere could exert drag on the planet's surface, potentially contributing to its slow rotation. However, this alone is unlikely to explain the retrograde motion. Core mantle dynamics. The interaction between Venus's mantle and core might also play a role. If the planet's interior dynamics differ significantly from Earth's, this could contribute to the unusual rotational behavior. The retrograde rotation of Venus has profound effects on various aspects of the planet, from its climate to its geological activity. Sunrise, sunset, and day-night cycle. Opposite sunrise and sunset. Due to its retrograde rotation, the Sun rises in the west and sets in the east on Venus, opposite to what we experience on Earth. Length of a day. A single day on Venus, one rotation relative to the Sun, lasts about 117 Earth days. This prolonged day-night cycle has a significant impact on the planet's temperature distribution and weather patterns. Extreme greenhouse effect. Venus experiences a runaway greenhouse effect, where heat is trapped by the thick atmosphere, causing surface temperatures to soar. The retrograde rotation does little to moderate these temperatures, resulting in an almost uniformly hot surface. A superrotation of the atmosphere. The atmosphere of Venus rotates much faster than the planet itself, completing a full rotation in just 4 Earth days. This superrotation is one of the mysteries of Venus, and its relationship with the planet's retrograde rotation is still being studied. Wind patterns. The slow rotation means that wind patterns on Venus are more influenced by solar heating than by the planet's rotation. This leads to massive, planet-wide wind systems that differ significantly from those on Earth. Volcanism. Venus is believed to be geologically active, with evidence of volcanic activity. The interaction between its retrograde rotation and internal processes might influence volcanic eruptions and tectonic activity, though this is not yet fully understood. Surface features. The retrograde rotation, combined with the lack of a significant magnetic field, might contribute to the preservation of surface features, as there is less weathering and erosion compared to Earth. Venus's retrograde rotation is just one of many puzzles that scientists are eager to solve. Several missions are planned to explore Venus in greater detail, with a focus on understanding its atmosphere, geology, and rotational dynamics. Veritas. This upcoming mission aims to map Venus's surface in high detail, providing insights into its geological history and any current geological activity. Understanding the planet's surface could shed light on how and why its rotation reversed. Uranus. While Venus rotates backward, Uranus has a unique axial tilt, almost rolling on its side as it orbits the Sun. Studying both Venus and Uranus could provide comparative insights into the various factors that influence planetary rotation. Earth-Moon system. The Earth-Moon system offers a contrast to Venus. Earth's relatively stable rotation and the Moon's synchronous rotation, same side always facing Earth, offer different perspectives on how celestial bodies can evolve over time. Venus's backward, or retrograde, rotation is a fascinating aspect of planetary science that continues to challenge our understanding of the solar system. Theories about its origins range from catastrophic impacts to complex interactions with the Sun, and the implications of this unique rotation extend to the planet's climate, atmospheric dynamics, and geological activity. As future missions to Venus gather more data, we may finally unlock the secrets behind this enigmatic planet's unusual behavior.